Continuing on with 13-4, solving using quadratic formula. Here's an example, and for those of you who attend office hours with me, you always hear me say I'm allergic to fractions, and I'm going to get rid of the fraction. And so I usually tell you to multiply by the largest denominator, which would be 3. But when I multiply by 3, I'm not going to get rid of the 2, so I'm going to do it quicker. And I'm going to multiply this by this, which is 6. And I'm going to multiply everybody by 6. That will get rid of both fractions at the same time. So I'm going to multiply everybody by 6. So that becomes 12c squared plus 6 times a half is 3c plus 6 times 2 is 12 divided by 3, which is 4 equals 0. Now, these are going to confuse you with the c's. Ignore. That's the variables, not the coefficients. So a is 12, b is 3, c is 4. Okay? All of them positive. These multiplied together bigger than that. Watch out. Okay, opposite of b plus or minus the square root of 3 squared minus 4 times 12 times 4 all over 2 times 12. This is going to be a negative. It's going to be a large negative. So it's negative 3 plus or minus the square root of 9 minus, and even when I multiply that, it's 48. And then I still have to multiply it by 4, which is 192 over 24. That is going to be a negative square root. It actually becomes negative 3 plus or minus the square root of negative 183 over 4 over 24, and that is a no solution. So the ones that pop out the easiest to me is when they're all positive and these two multiplied together and then times 4 is bigger than that squared. Okay, you're going to get into application problems. Quadratics are these U things. They are either used like this or used like this, but in application problems, you're throwing something up into the air and it's landing. I'm going to go through this where you're going up, there's a maximum height, and then it comes down. This is height equals 0, and this is height equals 0. This is where you launch it from. This is where it lands. Okay? The path of a ball that is thrown upwards can be described by the equation h equals 35t minus 5t squared, where h is the height of the ball in meters and t is the time in seconds. Pay attention when they declare their variables, because that will help you out. How high is the ball after 3 seconds? So this is, they're asking what h is after t equals 3. So not even in a quadratic sense, this is a substitution. So you're looking for h. 35 times 3 minus 5 times 3 squared. And that is 105 minus, that's 9, that's 9 times 5 is 45, and that is 60 meters. Okay, after how many seconds, so they're looking for t, will the ball be 50 meters high? So that's h. So you're going to say 50 equals 35t minus 5t squared. It's a quadratic equation. Going to pull, so the leading coefficient is a positive. So 5t squared minus 35t plus 50 equals 0. Set it equal to 0. I noticed that there's a 5 in there. I'm going to divide everybody by 5. T squared minus 7t plus 10. And if you notice, that's a We don't have to do it by quadratic. I can see that those are factors because these are the same. And this is the large is a negative. And I know that my factors of 10 are 1 and 10 and 2 and 5. And 2 and 5 give me 7. So that's t minus 5 times t plus, minus 2. Let me clean that up so there's no confusion. Minus 2 equals 0, so t equals 5 and t equals 2. So after how many seconds will it be 50 millimeters high? And so what you're seeing is it's going to be, say this is 50. So it's twice at 50 because it's at 50 high when it goes up. It hits a max, and then it's 50 high when it comes down. When will the ball hit the ground? H equals 0 is the ground. So I have 0 equals 35t minus 5t squared. I like making them positive, so I'm going to swing it around again. I'm going to factor out a 5 and a t. I'm going to set both equal to 0, 5t equals 0, and t minus 7 equals 0. So I'm going to divide, so t equals 0, and t equals 7, which basically tells me that from this right here, I started on the ground, I threw it up, it hit the max point, and it hit the ground after 7 seconds. So that's what this is telling you, that I started my clock, threw it up, 7 seconds later it hit the ground. That is 13-4, solving using quadratic formula again. Hitting on no real solutions, diagrams of objects, and how to use your variables to figure out your application problems.